In this video, we're going to work example problems on the fundamentals of complex or imaginary numbers. So, okay, for these first problems, we want to identify each number as being real, complex, pure imaginary, or non-real complex. But each number might fall into more than one of these categories. So I said that in this video, we're going to be working example problems on complex or imaginary numbers. But if we want to be technical about what exactly we're calling different numbers, we can think about the fact that, so even a real number is technically a complex number, right? All numbers that exist in mathematics, all numbers are contained within the complex plane, right? You got the imaginary numbers and then the real numbers. So all the infinite points that exist within the complex plane are all of the numbers that exist in mathematics. That represents all of the numbers that exist in mathematics. So, but the idea is, even if you're still on the, if you're just on the, have a pure real number, you're still in the complex plane. You just don't have an imaginary component, you see? And so the way that if you want to technically classify all numbers, then you have, so there's real numbers and then there's non-real complex numbers. Because again, like 5, the number 5 is technically, you can write that as 5 plus 0i. So it's still a complex number. Okay, but now if you have something like this, then this you call a non-real complex number. And if you have something like this, which you can write like 0 minus 4i, that's a pure imaginary number. Okay, so with that, how would we classify the number minus 4? Well, this is a real number, but it's also a complex number. So it's like it's you have all complex numbers. It's a subset of complex numbers. Okay, so this is a complex number. That's the biggest category. But then it's a non-real complex number. But then it also falls under another subcategory of being pure imaginary. Okay, so, you know, any number that you're given is going to be a complex number, no matter what it is. So it's always if you're dealing with a number, it's complex. Okay, but this is more specifically a non-real complex number. That's it. It's not pure imaginary. It's just a non-real complex number. Okay, this is a complex number. It's 0 or it's pi plus 0i. Right? But it's a real complex number. We just say real. Okay, well, this, we know that we can simplify this as I root 25. And we can go further. The principal root of 25 is 5, so 5i. And so that's, we can write that as 0 plus 5i, but so it's a complex number. It's furthermore a non-real complex number, but then it's even more categorized than that. It's pure imaginary. Okay, let's simplify the principal square root of minus 25. So we learned rules for simplifying square root radicals with negative numbers as the argument. We haven't learned anything about even radicals other than 2. Just note that. So this idea of, we learn that to simplify this, we can take out an I and then write this as That's what this is equal to. And then from here, we've got the principal root of 25. And so now that's fully simplified. But again, note that this rule here, we only learned this for square roots. We haven't talked about even roots other than 2 yet. And we also talked about the fact that you want to think about this as just like a rule for how to simplify this. So, intuitively you can think about it like it's kind of like having -1 times the square root of -1 times 25, the square root of 25, but you want to be careful with this because, you look at this and you can combine these two like that. And yes, that is kind of true, but you just want to be careful with this because as we know, when it comes to multiplying radicals, you're not supposed to do this, combine them like this if you've got a negative under one or both of the radicals. So, but yes, intuitively, you can think of the meaning of this sort of like this, in the sense that you start here, and then before you combine them, you change square root of -I into -1 into just I, and you're left with this. I mean, yeah, you can think about it that way, but just remember that this is a little bit tricky because you're not supposed to write it this way. You're not supposed to combine them this way. And I've explained why that's the case in the previous videos. Okay, so here we just take out an I and leave the positive root, and we can't simplify this anymore, so that's it. Okay, just start by taking out an I, and you're left with the positive root. So now let's see, what is 288 divided by 4? 7 times 4 is 28. So 288 is 4 times 72. What is 72 divided by 2? $36, and then 36 divided by 2 is 18. So we've got 4 times 4 times 18. 4 times 4 times 3 times 3 times 2. Okay, so we can take out a 4 and we can take out a 3. So we've got 12I root 2. And there you go. Okay, here we focus on this radical, and so we take out an I, and now we can get the positive root of 18. So 18 is 9 times 2, so we get minus 3I root 2. Okay, yeah, so here's an example where you cannot just do... Normally, we know just from general properties of radicals, if you've got something like, and really this applies for any radical, but right now we're with complex numbers, we're just focusing on square root radicals because the how you deal with complex numbers with even root radicals other than 2 is a little bit different than how you're going to deal with just square root radicals. But this does apply to any radical, and so you can combine these this way. Okay, but you can't just do this when you're dealing with a negative under an even root radical. You have to start by taking out all the imaginary information from the radical with a negative underneath it. Then you can go back to normal mathematics. That's going to be the general idea. If you're dealing with, it's not just about this kind of property, dealing with multiplying radicals. It's any situation where you might be wanting to solve an equation, so you're going to start multiplying both sides of an equation by something, or applying like a factoring formula or whatever. You don't want to do any math on that formula. You don't want to start doing math, properties, and operations until you've first identified, is there any like imaginary stuff wrapped up in a term, and you want to kind of take all that out first, then proceed forward with the math. Because otherwise what you can end up doing is, by just going forward with the math before taking out the imaginary components, you could defeat the whole definition of the imaginary numbers. So like if we combine these and got minus 13 times minus 13, okay, then we multiply that and Okay, square root of 169 is 13. Well, we multiply the 2 minus 1s together. And so, like, that's the whole idea. Like, whenever you have, like, extraneous solutions with radical equations, because you're squaring both sides, and it can create that issue with that comes when you square things. It's, like, not reversible. Well, that's what we've done here. So by doing this, we've defeated the whole purpose of why we defined I in the first place. And so that's why you don't want to do, it's not just about this property here, it's any property. You don't want to start doing math operations with when you've got imaginary components mixed into a term that you haven't taken out yet. So the idea is we're going to start by, we don't do any math properties here before we account for the imaginary numbers that are contained within these terms. Now we can go forward like this is just any other math problem, because we know that imaginary numbers, complex numbers, obey the same properties as any other number. So, okay, just multiply these. I squared, and we just combine square root of 13 to the two 13s, right? Like we normally would. We apply this property now. We can apply any math property we want now. So we've got 13i squared. I squared is -1. That's the correct answer. Okay, so we don't want to do anything until we've taken out the imaginary components. Okay, so now we can just combine these two like we normally would. So 8 times 3 is 24. 6 times 4 is 24. So 2i squared root 6. So that's -2 root 6. Okay, so we know there's a property of radicals. If you have this, then you can write that as this, but it's the same idea. We don't want to do any of that until we've accounted for all of the imaginary components and like simplified in terms of the imaginary components. So now we can move forward like normal. So this would be, these just divide out like that's just, you just treat I like it's any other number. And now you've got 30 divided by 10. So this is root 3. Okay, so I root 24 over root 8. Now we move forward. 6 times 4 is 24, so that's 2i root 6. 8 is 4 times 2, so that's 2 root 2. So you've got, let's see, I root 6 over 2, that's I root 3. Okay, so take out the i's first. Okay, now the i's cancel and we're left with, so this is going to be 1 over 2. Okay, you start by just simplifying any terms that have complex numbers contained within them. Then just use regular math operations to simplify. So okay, so we can do, this is I squared, so this is going to be 2i squared, which is -2. Okay, write each number in standard form, a plus bi. So, okay, yeah, this is interesting because another thing you want to think about when dealing with imaginary numbers or complex numbers in equations or whatever is that, yes, you can treat imaginary numbers like they're any other number. You can do whatever you want with them. But when you get to the end of a problem and you're trying to simplify everything and clean everything up and get like the final presented solution, you want to take all the imaginary numbers and like combine them with real numbers into like to show like their complex form. You don't want to just leave, you would want to just leave something like this. Or even, okay, you could combine these. So minus 8 plus 3 is, you wouldn't want to leave it like this either. It's not like this is incorrect, but you want to put everything into a form where you can see what the complex numbers are. Because again, that's how you present the number in terms of, we think of all numbers as existing in the complex plane. So you want to show the number as a complex number. So you want to put it like this. Even though this is not, there's nothing wrong with this, it's just not presentable. So if we started with something like this and we want to simplify, well, then we do, so minus 6 minus, and then take the I out of here before we start doing any other math operations. Now we can proceed with the math. So 6 times 4 is 24, so minus 2I root 6 over 2. Okay, now we might leave it like this, right? Like with problems that weren't dealing with imaginary numbers, we might leave a final solution like this. It's nice. It's one fraction. Sometimes you don't want to separate things up into multiple fractions. It's too messy. So this looks nice and clean, right? Well, no, not when you're dealing with imaginary numbers. We want to keep going and say, okay, minus 6 divided by 2 minus 2I root 6 divided by 2. And then you've got minus 3 minus I root 6. We want to come to this point because now we see the full complex number. Again, it's not like this is wrong. It's just you can't see as clearly what exactly the complex number is. Okay, so before we do anything, let's come to this radical here and take out all the i's associated with it. Okay, now root 200, we've got, let's see, 200 divided by 10 is going to be, we've got 200, and then that's 20 times 10. That's 2 times 10 times 10. So, okay, we've got 10 plus 10I root 2 over 5. Okay, do we stop here? That looks pretty nice. It's one fraction. No. Separate it into two separate numbers. So this is 2 plus 2I root 2. Okay, minus 3 plus I root 18 over 24. Okay, 9 times 2 is 18. Okay, so all right, minus 1/8 plus I root 2 over 8. So, okay, but let's write this to where we can clearly see the real part and the imaginary part. So root 2 over 8I, like that.